When we use ChatGPT, generate an image, or ask AI to solve a problem, it feels as if intelligence comes directly from the cloud. But the cloud is not weightless. Behind every AI response are physical chips consuming electricity, networks moving enormous amounts of data, and cooling systems removing heat 24 hours a day. AI may appear digital, but it depends on physical infrastructure. My name is James Cai. For more than 15 years, I have worked across energy, engineering, and sustainability. Today, I am focusing on AI data center infrastructure and liquid cooling solutions. In this video, I want to explain why AI requires a different kind of data center. And it begins with one important concept: power density. A traditional data center supports websites, cloud applications, business systems, and data storage. It already requires reliable electricity, backup power, cooling, fire protection, security, and continuous monitoring. But AI changes the scale and concentration of computing. AI systems use large numbers of GPUs and specialized accelerators. Hundreds or even thousands may operate together as one coordinated computing system. They must exchange data quickly, receive stable power, and remain within a safe operating temperature. The challenge is not only how much electricity the entire data center consumes, the challenge is also how much electricity is concentrated in one rack. This is power density. Many conventional racks operate at relatively low or moderate power densities, but high-density AI racks may require 100 kilowatts or considerably more. Emerging infrastructure designs are already considering 200 and even 300 kilowatts for a single rack. This is not a small equipment upgrade. It changes the requirements of the entire facility. Here is the fundamental physical principle. Electricity enters the computing equipment. The chips use that electricity to perform calculations, and almost all that electrical energy eventually becomes heat. Therefore, a 300 kilowatt AI rack is also approximately a 300 kilowatt heat source. To make that easier to imagine, it is similar to placing approximately 150 2 kilowatt electric kettles inside the footprint of one cabinet and operating them continuously. The engineering reality is more complex, but the physical message is simple. More computation requires more electricity. More electricity produces more heat. And that heat must be removed continuously and reliably. At very high rack densities, moving cooled air alone becomes increasingly difficult. Liquid can carry heat much more effectively than air. This is why liquid cooling is becoming increasingly important for high-density AI infrastructure. However, liquid cooling does not mean that air cooling completely disappears. Some components may still release heat into the room. In many projects, liquid cooling and air cooling must work together as one integrated system. Higher rack density affects much more than cooling. The electrical system must deliver more power to each rack. The cooling system must remove much more heat. The building may require stronger structural support, larger pipes, more cable routes, and sufficient maintenance space. The network must connect thousands of accelerators at extremely high speed. This is the real transformation. An AI data center is not simply a traditional data center with more GPUs, and liquid cooling is not simply one additional piece of equipment. AIDC is a system-level transformation involving computing, power, cooling, networks, buildings, operations, and sustainability. One clarification is important. Not every traditional data center must become an AI data center. Some existing facilities may support selected AI workloads. Others may not have sufficient power, cooling capacity, structural strength, or network connectivity. Many future high-density facilities will need to be purpose-built. The important conclusion is this: AI may live in the cloud, but the cloud has a physical foundation. Understanding that foundation will be essential for developing AI infrastructure that is reliable, efficient, resilient, and sustainable. In the next video, I will explain how rack density is evolving and why this changes the design of the entire building. If you work in data center developments, engineering, project management, or liquid cooling solutions, I would be pleased to exchange views with you. I am James Cai. Thank you for watching and welcome to the physical world behind AI.